Hello, everyone, and welcome back to Get Smart with Stanford. If you want to improve your math and pass with confidence, you are in the right place in here. Today, we're going to tackle number patterns, focusing on linear quadratic sequences just like you'll see them in your exams. Make sure you watch it till the end because I'll break everything down step by step so you fully understand, not just memorize. Now, let's get started with this grade 11 lesson. 3.1, we've got a pattern which looks like this. We've got 7. It's a linear pattern. So let me mention that it's a linear pattern which goes like, we got 7, 2, and minus 3. So when you look at it, 7, and because this is a linear pattern, that means we're basically going to get our first difference, not the second difference. So what is the difference here? The difference, to get the difference, as you all know, we'll say term number 2 minus term number 1. And term number 2 is 2 minus 7. So 2 minus 7 equals minus 5. And you can also say term number 3 minus term number 2, which is minus 3 minus 2 equals 5, equals minus 5, I mean to say. So we already have our common difference. Some of you are used to seeing it like I'm going to do now. You are used to seeing it like this: minus 5 minus 5. It's still the same. So it's very nice. 3.1.1 says determine the general term Tn of the linear pattern. Okay, what is the general term, or how do we get the general term Tn? We use this general equation, which is Tn equals A plus N minus 1D, and then whereby A is the first term and D is the common difference. Yes, A is the first term, D is the common difference. Fine. So what is the value of A? The value of A is the first term. The value of A is 7 and the common difference is minus 5. So we already have those two. Now what do we do with this term? We're going to substitute 7 here and we're going to substitute minus 5 here. Let us do that and see what we're getting. Okay, this is equals 7 plus n minus 1 into minus 5. Fine. The minus 5 will multiply each term that is in the bracket in here. Then we're going to have 7 plus what is n times minus 5 is minus 5n, and here we're going to have plus 5. Then we can swiftly remove the brackets because we are multiplying with a positive outside, so it's going to be 7 minus 5n plus 5. Then we group the like terms. What is 7 plus 5? 7 plus 5 equals 12, and here we have minus 5n. Then the general term which they want, which is tn, is equal to 12 minus 5n. You can also write it as minus 5n plus 12. It's still the same and it's still correct. 3.1.2. They say calculate the value of T20 or term number 20. How then do we calculate the value of T20 or term number 20? Since we have already found the general term of the general equation of this sequence, which we said Tn equals 12 minus 5n, then therefore T20, if you can look at it very carefully, you can see that here we have substituted n by 20. So we are going to do the same. We'll say 12 minus 5 multiply by 20. We multiply by 20. So what is term number 20? Term number 20 is 12 minus 5 by 20 is 100. Is 12 minus 100, which is going to give us negative 88. So if you had already found or calculated and got negative 88, then you are correct. Point 3. Which term in the pattern has the value of negative 138? That means our Tn equals negative 138. Then let us apply the very same formula or the very same equation which we have found on 3.1.1. 12 minus 5n. But right now they want to know the term number, which is n, and we already have our Tn, which is negative 138 equals 12 minus 5n. Then from here we can quickly transpose this one to the other side of the equal sign, and we will have minus 138 minus 12, which is going to give us minus 150. So with minus 150 equals minus 5n, then we divide both sides by minus 5n to get to make n the subject of the formula. Oh, not by minus 5n, but minus 5. Thank you. All right, then our n equals these ones will cancel each other, and minus 150 divided by excuse me, divided by minus 5 equals 30. So our n is equal to 30. We are done with question 3.1 of that type of a linear pattern. We've got question 3.2, which may seem to be very tricky for others and very simple for some. So I'm just going to give you the question or the pattern, and then we will take it from there. We are also given the second term as 2x plus 1 and 3x minus 3. These are the first three terms of a linear pattern. And now we are required let me just circle this. You can see we've got x here, we've got x here, and we are required to calculate the value of that x. So now they want us to find x. What is x now? How do we calculate x? You will remember very well that this term is equal to term number 2 minus term number 1. So term number 2 is 2x plus 1 minus term number 1, which is 6. And this difference here is term number 3 minus term number 2. Our term number 3 is 3x minus 3 minus term number 2, which is 2x plus 1. So nice, eh? Yeah. So since we have a common difference here, that basically means this first difference is equal to this second difference, because it's a linear pattern and we have a common difference. So on this one, to simplify, on the first one, the first difference will have 2x, 1 minus 6 is, we'll have 2x minus 5, and this one will have 3x minus 3 minus 2x minus 1. Then grouping the like terms, 3x minus 2x equals x, and then minus 3 minus 1 equals minus 4. So to simplify this, or to work on this one, we know that the first difference is equal to the second difference, because they are the same. If our difference is 1, then it's 1 1 1. 1 is equal to 1. If our difference is 2, then it's 2 2 2. Then our difference is 2. So we don't know as yet as to exactly what is the numerical value of our common difference. We're going to find out very soon. Watch this. We're going to say 2x minus 5 equals x minus 4. Of course, they are equal. Then we transpose, we can take this x this side and the minus 5 this side, just so to group the like terms. Then here we'll have 2x minus x, because the x here will change, and the minus 5 will change to positive on the other side. Then we'll have positive 5 minus 4. All right, 2x minus x is x, and then 5 minus 4 is 1. Then we are done. But then to prove, or to prove to you that we have a common difference, or to show, to check uh, what is the numerical value of the second and the third term, then we can easily come here and substitute. I've made a blue dot there. I hope you can see it. Now let us substitute that x by 1, because they say here x equals 1, and also here we substitute that x by 1. Then this will be 2 plus 1, and the second term will be 3, and 3 minus 3, this one will be 0. So that means our common difference is 3. Our common difference is 3. It was never asked in the question. We were only asked to calculate the value of x for 3 marks. So I'm just giving you a bonus in case we were to be asked such questions. Now let us look into question 4. Question 4 can be very tricky because it's now a quadratic pattern. A quadratic pattern, we normally have our common difference in the second line of difference. in the second line of the sequence. Now they say the quadratic number pattern, we've got 4, we've got 4, we've got P, we've got 11, we've got Q, we've got 22. So with these we've got two unknowns here. And what are those unknowns? We've got P and Q. We don't know what the value of P is. We don't know what the value of Q is. Now, let us look onto the questions. 4.1, they say show that P equals 7 and Q equals 16. Get to see that here. P equals 7 and Q equals 16. How do you get to know that now? Let us first break it and make it much simpler. Let's go to the other screen. So we know that the difference here is going to be P minus 4, and the difference here is going to be 11 minus P. The difference here is going to be Q minus 11. The difference here is going to be 22 minus Q. And we are further told that this quadratic sequence has a constant second difference of 1. So they say the second difference is 1 and it's constant amongst all of them and amongst all of these terms. Different color. That means here we've got 1, 1, 1. So what does this tell you? It tells you that in the second sequence, in this sequence that I've written here in red, I've just circled it with a blue color now. In that sequence, term number 2 minus term number 1 equals to 1. And term number 2 is 11 minus P. Okay, so now that we have that information, let us use that to our advantage. We are going to use that to our advantage. They say term number 2, which is 11 minus P, minus term number 1, which is P, minus 4. They say this is equal to 1. Okay, now let us simplify this even further and see where it gets us to. We've got 11 minus P plus 4 equals 1. Then what is minus P equals minus 2P. This is equal to, what is 11 plus 4? That is 15. We transpose to the other side, then we have 1 minus 15. 1 minus 15 equals minus 14, and on the other side we have minus 2P. So I'm sure you can already see where this is going. Then we divide both sides by -2 to leave P as the subject of the formula. Then these ones are going to cancel, and this side we are left with P. Minus 14 divided by minus 2 is equal to positive 7, and we have proven what they wanted us to prove. The first one, of course, we haven't proven the Q as yet. So now that we have proven the P, we have proven that, okay, I'm sure this is closing. We have proven that P equals to 7. Let us now go and prove that Q is equal to 16. All right. We will use term number 3. Term number 3, which is this one. I've just made a dot there with a black. That is term number 3 minus term number 2. We can also use term number 3 minus term number 4 minus term number 3. So because it has q and we need to find what the value of q is, so they say q minus 11 minus p is equal to 1. That is what we've been given. We are not fabricating this. Then we also know that the value of p already, which is equal to 7. We have calculated that. So we can substitute this and say 11 minus 7. Okay. Then here we have got q minus 11 minus what is, I beg your pardon, what is 11 minus 7 equals 4, positive 4. Then we'll multiply with the negative that is outside on the left. It will just be this. What is minus 11 minus 4 is minus 15. Then we're going to transpose it. We transpose this minus 15 to the other side. Is going to be positive 15, leaving q on as a subject of the formula. Then we've got 1 plus 15, which gives us 16, as we have been required to prove. So now we have proven that p equals 7 and q equals 16, which is so nice. Then so far so good. Let's go to the next one and see the second question. They say determine the general term Tn of the quadratic pattern. Before we can determine that, let us substitute those unknown values at the top there by those that we've just calculated now, because we already know what the value of p is. We already know what the value of q is. So here we can substitute this, put 7, put 16, because that has been proven. Get smart with Stanford. Thank you so much. Thank you for the likes, thank you for the follows, thank you for everything. Now let us continue. They say we must determine the general term. Determine the general term Tn of the quadratic pattern. How do we determine that? We already know that the general one is Tn equals an squared plus bn plus c. This is just a refresher of what you've been doing from grade 11, from grade 10, when you were doing the quadratic equation. This is the basic of the quadratic equation, being in the form ax squared plus bx plus c. So it needs to remind you that, then you'll be able to understand where we're coming from and probably where we are going. So now that the common difference is from the second sequence, then 2a equals 1. This you already know by now. Then we'll divide both sides by 2, then our a will be equal to half. Okay, that is so nice. So we can just quickly erase the a and substitute it with a beautiful half, because we have calculated that. Yeah. And now we need to find the values of b and c. How do we find those values? When n is equal to 1, when n is equal to 1, that is which number? That is when Tn is equal to 4. Term number 1 is equal to 4. All right, fine. So we're going to substitute here by these values. We'll have half into 1 squared plus b into 1 plus c, we said it's equal to 4. We are equating it to 4. When you multiply this, 1 square is just 1. 1 times half is just 1 over 2 plus b plus c equals 4. And then from here, let us group the like terms, because here we've got variables and our variables is b plus c. Let's leave variables on one side and then put the numbers on one side. Here we'll have 4 minus 1 over 2. Let me use my calculator, but do I really need a calculator here? Because this is 3.5 and 3.5, that is 7 over 2. Okay, so 4 minus half is 7 over 2. It looks like there's nothing much that we can do with this one, so let's just make it equation number 1. Right, open up a space here. Let's open up the space. We've got equation number 1. Now, when n equals 2, then what is that? Let us look at the sequence. That is the p that we have calculated to find 7. Let me, n is equal to 2, that is the second term. Then the second term is 7. Then we're going to substitute with those. Then we will have half 2 squared plus b 2 plus c equals 7. Half squared equals to 4, and 4 times half is 2 plus 2b plus c equals 7. Now let us continue to group the variables one side. We've got 2b plus, I think this will be a little bit confusing. Let me rather not write it there, but here 2b plus c equals 7. Then the 2 will transpose to the other side, is going to be minus 2, and 7 minus 2 equals a beautiful 5. Let's make this our equation 2. Now let us substitute equation 1 from equation 2. That will be equation 2 minus equation 1. Equation 2, we've got 2b minus b on the equation. Okay, let me rather put it here so that everybody can see. Here is equation 2b plus c minus b plus c equals 5 minus 7 over 2. That's how it is. Then we'll have 2b plus c minus b minus c equals, what is 5 minus 7 over 2? 5 minus 7 over 2 equals let me take my calculator. 5 minus 7 over 2, that is equal to 3 over 2, equals 3 over 2. Then 2b minus b equals b, c minus c equals 0, then b equals 3 over 2. Okay, now that we've got the value of a and the value of b, let us take the value of b and substitute into any equation. Whether you substitute into equation 1 or equation 2, you still are going to get the same answer. I opt to substitute into equation 2 So I'll say substitute this value into equation 2. Then we'll have 2 into 3 over 2 plus c equals 5. These beautiful 2's will cancel, unfortunately. Then we'll have 3 plus c, and then c equals, we transpose the 3, we'll have 5 minus 3, which gives us 2. So now we've got all the values. We've got a, b, and we also have c. All right. So now that we've got the values of a, b, and c, let us go on to see how we continue. We are just going to substitute these values onto that quadratic equation. Remember, our quadratic equation is and we already know the value of a, which is 1 over 2. The value of b is 3 over 2. The value of c is 2. I'm sorry. The value of c is just 2. The value of c is just 2. What was the question? The question required us to determine the quadratic pattern, and here is the quadratic pattern. We've got it here. All right. Now that we've got that quadratic pattern, they say determine the value of n if Tn equals 300 and determine the value of n if Tn equals 232. Remember, the quadratic formula is like this. Then now they say Tn, let us put it on the other side. We've got half n squared plus 3 over 2n plus 2 equals 232. Fine. All right. Then we're going to transpose this and bring it here. Then we will see where it takes us to. But before we can do that, let us try and reduce these fractions. You see, if we can reduce these fractions, it will be much easier to work with this equation. So let us multiply each term by 2. The reason why we are multiplying by 2 is because we can see that the denominator is 2. Then if the denominator is 2, then the 2's will cancel. And then here we'll be left with n squared plus 3n plus 4. We are multiplying each term. What you do on the left hand side, you also do on the right hand side. This is going to be 464. Okay. Now let us transpose. Then we'll have n squared plus 3n plus 4 minus 464 equals 0. Then n squared plus 3n, 4 minus 464, this is just minus 460 equals 0. Your calculators are very clever these days. you will be able to factorize. Now let's factorize. We know obviously that here we're going to have n, and here also equating to 0, and then our factors are going to be minus 23, or n will be equal to 20. No, we cannot have both of them as positive. It will not give us. Yes, we've got it like this. But remember, when we're counting the number of terms, we can never have a negative. Then n is equal to 20 only. N is equal to 20 only, simply because we can never ever have a negative term in mathematics. That just doesn't make sense, right? When you are counting, they say go and count the apples. You can never say, I saw minus 5 apples, they were there in the bowl. So you'll never have a negative count. Fine. So we've got the last question, which carries 5 marks. The sum of two consecutive terms in the pattern, that is the pattern that we're talking about, is equal to 1227. 1227. So if the sum of when they say the sum of two consecutive means they are following each other. If the other one is at number 1, the other one will be at number 2. If the other one is at number 11, the other one will be at number 12. So that's what they mean by consecutive. And now the sum of those two consecutive terms in the pattern is equal to 1227. That means when you add those two terms, you're going to get 1227. Now, let's say calculate the difference between these two terms. Firstly, we don't even know which terms these are. Calculate the difference between these two terms. We don't even know which two terms they are talking about here. How then do we know their difference? How then do we calculate their difference? We only know their sum. Okay? Fine. Which terms are they talking about now? It's like this. Say you've got the other term, if it's Tn, then the next term is going to be Tn plus 1. All right? They say these two terms is equal to 1227. Okay? So I'm sure you're asking yourselves, why did I say Tn and Tn plus 1? Tn is just a term number. If n is equal to 1, then that means it's term number 1. And then the second term will be n plus 1. That will be 1 plus 1. That will be term number 2. That's how they follow each other. Even if it's term number 1000, the next term will be n plus 1, which is 1000 plus 1. That gives you term number 1001. So we don't know as yet which term number it is. We only know that it's a term number, a certain term number, and the next term number. So their sum is equal to 1227. So now we already know what Tn is. I'm talking about these Tn. Okay, the one in the circle is the Tn I'm talking about. We have already calculated and found that it's equal to half n squared plus 3 over 2 n plus 2. And we say plus, we've got n plus 1. That means wherever we find n, we are going to put n plus 1 this time. So what is that n plus 1? We're going to be the same equation, but instead of n, it's n plus 1 squared plus 3 over 2 n plus 1 plus 2. They say these are equal to 1227. I'm sorry about that. Let me fix it. It's not 1221, but 1227. Fine. Let us first deal with this big one on the left hand side before we can touch the 1227. I just wanted to see if you're half, and when you multiply out n plus 1, n plus 1, that's the same as n squared. You get n squared plus 2n plus 1. So it's going to be like that. And here you multiply out, you've got 3 over 2n plus 3 over 2 plus 2 equals 1227. 1227. It's fine. And then we're going to multiply this half with whatever that is inside the brackets. Then we're going to have half n squared plus 3 over 2n plus 2 plus half n squared. Let me erase the line. Plus half times 2, that is equal to 1. Then it's going to be just n. Half times 1, that is equal to half, plus 3 over 2 n plus 3 over 2 plus 2 equals 1227. Okay, so in this case, now that everything seems to be lined up correctly, let us group the ones that are likes. Let us group the like terms. We've got the ones with the squares. I'll just circle them in red. And the ends that do not have the squares, I will circle them with a blue color. Where's the other end? It's here. Okay, that's the one. And I'll use the green one to circle the numerical values. Can I use the green, or let me rather use the yellow? I'll use the yellow to circle the numerical values. Okay. Colors. Let us start with the squares. We have half n squared plus half n squared. Half plus half equals 1. Then that basically means we just have n squared. Simple as that. And the ones with n's, these are the ones in blue color. We have 3 over 2n plus 3 over 2n. Let us punch our calculators and see what it gives us. 3 over 2 plus 1 plus 3 over 2. That is giving us a, what do we get here? I think we're getting a 4. Then we're getting plus 4n. And the numerical ones, or the constants, we've got 2 plus a half plus 3 over 2 plus 2. That should give us a 6. We've got a 6. And then now we can transpose the 1227 to make it minus 1227 equals a 0. Then n squared plus 4n. 6 minus 1227 is negative 1221 equals a 0. Let us try and find the factors of this. And if we fail to find the factors, that means we are going to try and use the quadratic equation or the quadratic formula. So here we are going to, your calculators are very smart these days. You can find the factors without a hassle. Then here we obviously are going to have n and n equals 0, not 6 but 0. And then okay, 37 times 33 is equal to 1221, and it also gives us the 4 that's in the middle. Okay, then that's so nice. That is so nice. Then n equals minus 37, or n equals positive 33. But when we are counting, we cannot have a negative. You cannot go to the fridge and say, Mama, I can see negative 3 apples in the fridge. No, they have to be positive all the time. So our n is equal to 3 only. It's equal to 33 only. Okay? So now we know that we've got term number 33. They say they are consecutive terms. So it's term number 33 plus term number 34 equals 1, 2, 2, 7, as it has been given. Fine. I am very happy with this. So now they say we must find their difference. If you can still remember very well, the question says calculate the difference between these two terms. Okay, we are going to say term number 33 minus term number 34. So what is term number 33? So we substituted n with 33, then we're going to have half into 33 squared. Now, what am I doing? 33 squared plus 3 over 2, 33 plus 2. Oh, this is equal to, let's punch our calculator. It's 596. And term number 34, we've got 1 over 2 into 34 squared plus 3 over 2 into 34 plus 2. Then let's punch our calculators and see what this is. blah 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 blah. This is equal to 631. 631. So now that we've got 631, they say we must find their difference. Term number 34 minus term number 33. That is 631 minus 596. Let us see what that is equal to. 631 minus 596. That is equal to 35. The difference between these two terms equal to 35.